Earth's orbit in danger. Space junk crisis. Have you ever heard about the Kessler syndrome? It refers to a scenario in which a collision triggers the cascade effect. I'll clarify this concept in this video. Well, our main focus will be on the space junk or debris that will lead Earth towards the danger zone. Let's dive in. First, let's see what space junk is. Space debris refers to the artificial objects that are floating in space that no longer serve any useful purpose. These objects can be anything from old satellites and rockets that were converted into debris from collisions or discarded parts from spacecraft. Because space is vast, these items can stay up there for a long time, travelling at high speeds. They are a significant risk for the spacecraft and satellites. Moreover, scientists and engineers are actively working on ways to track them and figure out how to clean up the space junk to keep our orbits safe. Before moving forward, let's look at the characteristics of space debris. Space debris includes a wide range of objects, from tiny fragments smaller than a millimetre to large pieces, including inactive satellites and discarded rocket stages that weigh several tons. Despite their tiny size, smaller debris can cause significant damage due to their high velocities, reaching up to 28,000 km per hour. On the other hand, larger debris pieces can pose a severe threat because its mass can result in catastrophic collisions, producing even more fragments. The composition of space debris is diverse, including metals, plastics, ceramics, and composite materials derived from spacecraft, rocket bodies, and fragmented remains of past collisions or explosions. One of the most significant characteristics of space debris is a high kinetic energy, resulting from its velocity in orbit. Even the smallest bits of debris in space pose significant risks to spacecraft because of their incredibly high velocities, which can cause extensive damage. A collision with a piece of debris as small as a centimetre can create a hole in a satellite or damage sensitive instruments, leading to mission failure. The velocity of space debris varies depending on its orbit, but in LEO, low Earth orbit, debris can travel at speeds of around 7 to 8 kilometers per second. One more significant characteristic of space debris is its presence at higher altitudes, especially in geostationary orbit and beyond. While low Earth orbit is more densely populated with space debris, the debris at higher altitudes presents unique challenges due to the different orbital dynamics and the critical function of satellites. On the other hand, the geostationary orbit is situated approximately 35,786 kilometers above the equator. This orbit is highly valuable for communication satellites, weather monitoring, and other critical applications that require constant coverage of particular regions. The characteristics of space debris at this altitude include longer orbital lifetimes and more complex tracking and mitigation challenges. Because GEO is much further from Earth than LEO, any debris at this orbit takes significantly longer to decay naturally. Objects can remain in GEO for decades or even centuries without intervention. It increases the chances of collisions and the debris accumulates in space. Well, what are the other potential reasons for space debris? One primary source of space junk is satellite fragmentation. Satellites can break apart due to internal malfunctions, collisions with other objects, or explosions of residual fuel and batteries. Such events generate numerous smaller fragments that can last in orbit for years, contributing to the debris population. Another substantial reason for space junk is rockets and boosters. After deploying payloads into orbit, these components often remain as debris. They range from large rocket parts to smaller parts like fairings and engine components, adding to the debris in space. Furthermore, discarded equipment such as spacecraft components, tools, and deployed mechanisms like solar panels and antennae also contribute to the accumulation of space debris. Intentional actions like the deliberate destruction or deactivation of spacecraft can also generate debris. It's done to prevent future collisions or to terminate a mission. Additionally, historical space missions have left behind significant debris, especially from early space exploration. The lack of deorbiting practices for older satellites and space debris further exacerbates the problem, as these objects remain in orbit indefinitely without means to safely remove them. Natural causes, such as collisions with micrometeoroids and other space debris, also contributes to the formation of new debris. Now, finally, we will discuss Kessler syndrome. The Kessler syndrome occurs when the density of objects in low Earth orbit is high enough that collisions between objects could cause a cascade. Every collision produces space debris, raising the probability of other additional collisions. This ongoing chain reaction could make more and more pieces of debris, possibly making some orbits around Earth unusable for a long time. In Kessler syndrome, space debris also becomes so dense that collisions happen more often than objects naturally falling back to Earth's atmosphere and burning up. This process can rapidly increase the amount of space junk, turning the area near Earth into a dangerous field of fast-moving debris. Such an environment will pose significant risk to active satellites, including those critical for communication, weather monitoring and navigation, potentially disrupting modern life as we know it. The consequences of the Kessler syndrome are horrifying. For one, the increased risk of collision could make it exceedingly difficult to maintain and launch new satellites, impacting industries and services that rely heavily on satellite technology. Moreover, the accumulation of space junk threatens crewed missions, endangering the lives of astronauts aboard the International Space Station. Before I move on, let's subscribe to the channel so you don't miss any updates. Now the question is, in what ways does space debris pose a threat to Earth's orbit? So, mainly, it's due to the increased risk of collisions. The accumulation of defunct satellites, spent rocket stages, and fragments from disintegration and collisions create a hazardous environment in low Earth orbit. This debris can travel up to 28,000 kilometers per hour, making even small pieces capable of causing catastrophic damage to operational satellites and spacecraft. The presence of space junk also poses a direct threat to active satellites. These satellites are crucial for various services, including communication, navigation, weather forecasting, and scientific observation. Collision with debris can disable or destroy these satellites, leading to service disruptions that impact daily life on Earth. For instance, communication blackouts, impaired GPS services, and reduced climate monitoring capabilities can have far-reaching consequences for civilians and military operations. Now here's the important point. Space debris also impacts space exploration by increasing risks, complicating mission planning, and potentially hindering future planning. Space junk also endangers human spaceflight. The International Space Station and other missions face significant risks from debris impacts. Even small fragments can puncture spacecraft, potentially leading to loss of life and mission failure. This danger requires constant monitoring and debris avoidance, which are resource intensive and reduce the overall efficiency of space missions. Space debris also complicates the launch of new satellites and space missions. The crowded orbital environment increases the risk of collision during launch and early operation phases, posing a challenge for space agencies and private companies. This increased risk can lead to higher costs and more stringent safety measures, potentially slowing the progress of space exploration and commercial activities. The crowded nature of certain orbits makes it more challenging to find safe launch windows. Space agencies and private companies must carefully plan launch trajectories to avoid existing debris, which can lead to delays and higher costs. It slows down space exploration. Scientific missions also require precise orbits to conduct observations and experiments. Space debris can limit the availability of these optimal orbits, forcing missions to compromise on their scientific goals. For example, telescopes and Earth observation satellites might have to operate in less favourable conditions, reducing the data quality they collect. The accumulation of space debris has a long-term effect on future endeavours in space exploration. As more debris accumulates, the risk of collision increases. It can restrict access to space for future missions, including ambitious projects like lunar bases, Mars missions, and deep space exploration. Moreover, space exploration often involves international collaboration, with multiple countries contributing to and benefiting from shared missions. Space debris complicates these efforts by introducing additional risk management and coordination layers. What strategies can be implemented to decrease space debris? Designing satellites and rockets to minimize debris generation is a crucial strategy in space debris removal. This strategy includes measures such as passivation, where all stored energy, such as residual fuel and batteries, is depleted at the end of a satellite's mission to prevent explosions that could generate debris. Additionally, designing components that are less likely to fragment upon collision is crucial in preventing the creation of new debris. Another strategy is the active debris removal strategy. It involves the physical removal of existing space debris from orbit. For instance, ground-based laser systems can target small debris in lower orbits where they will eventually burn up in the atmosphere. Addressing the challenge of space debris also requires international collaboration and regulatory measures. The Interagency Space Debris Coordination Committee has developed global guidelines and best practices for reducing debris creation and managing existing debris. Establishing international laws and regulations is essential for enforcing these guidelines. Technological innovation and ongoing research are essential for developing effective debris removal solutions. Autonomous satellites and drones with advanced AI and machine learning algorithms can improve the detection, tracking, and prediction of debris movements, enabling efficient debris removal operations. Now, let's recall some crucial pointers from today's video. Space debris, orbital debris, or space junk includes non-functional, human-made objects in Earth's orbit. It originates from past space activities, including collisions, explosions, and discarded equipment. Space debris is scattered in different orbits around the Earth, with lots of it in low orbits close to Earth and geostationary orbit. Cleaning up this debris is tough, but is essential to keep space missions safe and protect the areas where future space exploration will happen. So there you have it, guys. Share your thoughts, perspectives, or any questions in the comments section.